Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my teaching, please press the like button, share the videos with your friends, and subscribe to my channel, and even press the bell button to get the regular updates. In the last few videos, we have discussed about the modes of I/O transfer. One is programmed I/O, then we have interrupt driven I/O, then we have direct memory access. In one of the video, we have discussed about the programmed I/O in detail, and even we have discussed the drawbacks in the programmed I/O. Then we have discussed about the interrupt driven I/O. Then even we have discussed about the priority interrupts and how to implement the priority interrupts with the help of software and the hardware we have discussed. Like in software, we have discussed about the polling based mechanism, and then in the hardware, we have discussed about the serial connection and the parallel connection. What is the drawback of the interrupt driven I/O? There is a context switching whenever there is an interrupt. Let me discuss with a simple example. You are playing a PUBG game, okay, and your father is calling you in a phone call. He is calling you in a phone and you are playing the PUBG game. So as you know that your father is high priority as compared to the playing the PUBG game, then obviously it is an interrupt for you and it is a high priority interrupt. Whenever there is a high priority interrupt occurs, you have to do the context switching and do the corresponding task. So in this case, what you will do, you will stop playing the PUBG game and you will lift your father call and you will talk with your father. So you have done a one context switching by pausing the PUBG game and lifted the father's phone call. After once the conversation is completed, then what you will do, you will end the call and again you will resume the playing the PUBG game. So again you have done the context switching. So whenever there is an interrupt occurs, you have to do the context switching, which is an overhead. Then people have thought, does we have any other solution? The solution they have found is the direct memory access. Okay, so let me discuss about the direct memory access first. Then we will discuss about the direct memory access block diagram. I hope you will understand the entire concept after watching the complete video. So I request everyone to watch the complete video, then you can ask the doubts whatever you have. Okay, so now let me discuss about the direct memory access. Usually we have a CPU and we have a I/O devices and we have the main memory or the memory. Now, to transfer the data, as everyone know that we need a system bus. What is the system bus? It consists of address bus, data bus, and also control bus. The data bus will be useful for transferring the data, address bus will be useful for transferring the address, and then control bus is used for to send the control signals. So, whenever we have a system bus, then only we can start transferring. As everyone know that the system bus is under the control of CPU. The system bus is under the control of CPU. That's why we'll call it as the CPU is the bus master. Now, that's why in the programmed I/O and interrupt driven I/O, if the data need to be transferred between the I/O device and memory to I/O device, the CPU intervention is there. Am I right? In the programmed I/O, the CPU is doing the busy waiting. Am I right? Whereas in interrupt driven I/O, it will give the either read or write signal and then it will do the task. Whenever there is a status register flag is 1, then we will send an interrupt, then CPU will come and execute the operations. So, in the programmed I/O and the interrupt driven I/O, the CPU is playing a major role. When it comes to the direct memory access, people have reduced the role of the CPU by introducing a new terminology called direct memory access controller. What this direct memory access controller will do is that it will reduce the burden on the CPU. How it will reduce the burden on the CPU? By taking the charge of the system bus. Okay, so if as you know that the system bus is under the control of CPU, so what the DMA controller will do, it will request for the system bus. Whenever the CPU grants the bus grant to the DMA controller, then the system bus is under the control of DMA. Then CPU is free to do other instructions. Okay, so then what the DMA controller will do? It will act as a mediator between transferring the data from IO device to memory and memory to IO device. So the entire burden from the CPU has taken by the DMA controller. So I hope you have understood how the DMA controller will work. So instead of CPU, DMA controller is taking charge of the system bus and transferring the data from IO device to memory and memory to IO device. So now let me discuss about the DMA block diagram. As I said earlier, we have a CPU, we have the memory which is a main memory, we have a DMA controller, we have IO devices. Let me discuss each pin, then we will go for the complete detail of execution of operation. We have an interrupt pin to know the interrupt, because DMA controller can send an interrupt, then you will have the interrupt to the from a DMA controller to the CPU. And then we have a bus request. Is it clear? BR stands for bus request. Who will request for the bus? DMA controller will request for the bus to the CPU. And then if CPU want to give the bus, then it will send a bus grant signal to the DMA controller. We have various pins in the CPU. Just I am discussing the pins which are required in the DMA block diagram. And then we have R, W, A and D. R stands for read signal, W for write, A for address and D for data. Okay. Similarly, in DMA control will also we have read, write, address and data. And comes to other pins, we have address select, okay, which can be selected by the CPU. Then we have the device select, okay, or we can call it as a DMA select. We have a register select. See, DSC stands for DMA select or device select. RS for register select. We have 3 registers I will discuss. And we have a bus request, bus grant and interrupt pin. Comes to this one, AR for address register, WC for word count, CR for control register. You can ask me, sir, why you written in shortcut, why you have, because of the space constraint I have written everything, so that I am explaining here. So I request everyone to note down this diagram and then write the each terminology when I am discussing. It is an address register, word count and control register. Now let me come about this register select. This register select is a 2-bit pin. One is RS0, RS1. Using 2 bits, as you know that we can select the 4 combinations. Am I right or wrong? If it is 2-bit number 00, 01, 10, 11, 4 combinations can come. However, we have 3 combinations here. So whenever it is 00, it will select the means RS0, RS1 is 00, it will selecting the address register. If it is 01, it will select the word count. If it is 10, it will select the control register. So these register selection can be done with the RS, which is in RS0 and RS1 internally. Okay, I hope you have understood about this RS0. And similarly, in the memory also we have read, in write control signals, and we have address and we have a data. Now the connection is there from read to read, this read also. So this one we'll call it as a read control bus. This one is a control bus for sending the read, and this is also write. Okay, and this one if you see that address is connected to this address, okay, and also to this address. So this one is an address bus, and we have a data bus, and the data bus is connected to IO devices also. So I hope you have understood this diagram. Now let me discuss about the operations. Okay, suppose let's take that IO device want to have a data transfer. So what it will do is that it will send a request to the DMA controller with the help of DMA request. It is sending a request to the DMA controller. Once a request comes for the DMA for the purpose from the IO device to transfer the data, then it will ask for the bus request to the CPU. So it is requesting for the system bus to the CPU. Then if CPU is ready to give the system bus, it will send the bus grant signal. Are you able to understand? This BR and BZ are useful for bus request and bus grant. So DMA controller will ask for the bus request, CPU will give the bus grant. While it is giving the bus grant, it will even send this information like read, write, address and the data. So what is the purpose of this address is, in which memory location you want to do the read or write. Because address register will consist of the address in which memory location you want to do these operations, like either read or write will be discussed with the address. Then W count will tell how many words you want to read or write. Is it clear? If you want to do the burst, I will discuss about the burst and cycle. Let me tell you now, it is that how many words you want to do it. And control register will tell whether you want to perform the read or write. Is it clear? If you are performing the read operation, then the control register will consist of a read signal. If you want to perform the write, then it will consist of the write signal. Okay. Now come to this one. Once the bus grant is given by the CPU, the DMA will send the acknowledgement to the IO device that I have the control over the system bus. Now you can start transferring the data. Are you able to understand? So let me discuss again. IO device is sending the DMA request. Then bus request permission is asked for the CPU, and CPU is given the bus grant, and even it has specified the address, all these things. Okay. Then DMA acknowledgement was sent to the IO device. Then the data will be started transferring. Now data transmission can be done in two modes. One is that burst mode and another one is cycle stealing mode. Now you can ask me, what is this burst mode and what is the cycle stealing mode? This burst mode will be useful whenever the data transfer is happening between the IO device, which is a high-speed IO device. Okay, as we know that in IO devices we have the high-speed devices, slow devices also. So if you are transferring the data from high-speed IO device to memory or memory to high-speed device, then we will use the burst mode mechanism. If it is a slow device, then we will go for the cycle stealing mechanism. In burst mode, what will happen is that we will send a large number of words at a time. Meaning is that one word only we will send, but the word count will be more than one. It will be can be 10 or 20 or anything. So meaning is that 20 words you are selecting at a once. Meaning is that once you request for the bus, you will send the 20 words, then only you will release the bus. Are you able to understand? So in burst mode, the word count will be some 20, 10 or anything. The meaning is that 20 words you will send, then only DMA controller will release the system bus to the CPU. Then coming to the cycle stealing mechanism, we will send one word at a time. Meaning is that you will ask for the bus, you will send one word and you will again release the bus request back to the CPU. So then when it will be useful is for slow devices, which is such as a keyboard, because it will send one word at a time, means one byte at a time. So there we will use this cycle stealing mechanism. If it is high speed devices, then we will go for the burst mechanism. Okay, now let's take that you want to send 10 words. The 10 words will be selected transferred between the IO device and the memory or memory to IO device. Okay, then once it becomes 0, DMA controller will release the bus. How it will release the bus is that it will send an interrupt signal to the CPU. Then CPU will understand that, okay, the DMA controller has finished its task, and then it will keep the 0 on the bus grant. Are you able to understand? Because initially it was 0. Then when the CPU has given the bus grant, it was 1. So that's why DMA controller has taken the control of the system bus. Now once the interrupt was sent by the DMA controller to the CPU has understood that DMA controller has completed its task. Again I need to take the charge of the system bus. How it will do? By the bus grant keeping it 0. Meaning is that it stopped giving the permission of the bus grant to the DMA controller. This is the way the communication will happen between the CPU, memory, DMA controller and IO device with the help of the block diagram we have discussed. I hope you have understood the concepts whatever I have discussed. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts in less than 24 hours. If you really like my video, please press the like button, share the videos with your friends, subscribe to my channel and even press the bell button to get the regular updates. Thank you for watching my video. Have a nice day.